Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good afternoon. My name is Kirsten Wiley, and I'm here today to introduce and welcome Stephen Baker, who is visiting us as part of the Microsoft Research Visiting Speaker Series. Stephen is here today to discuss his book, Final Jeopardy! Man vs. Machine and the Quest to Know Everything. For 3 nights in February 2011, IBM's computer sensation Watson battled human champions Ken Jennings and Brad Rutter in an epic match on the quiz show Jeopardy! When Watson trounced the competition, it leaves many of us wondering what the future looks like. How do smart machines fit into our world, and how will they disrupt it? Stephen Baker was Business Week's senior technology writer for a decade. He is the author of The Numerati and has written for the LA Times, Boston Globe, and the Wall Street Journal. Please join me in welcoming him to Microsoft. You're unplugged.
Oops, I'm unplugged. Okay. Is this the microphone? Yeah.
Yeah.
Okay. So little. Okay. Hi, everybody. Thank you for coming. As I was here 3 years ago, a little over 3 years ago, to talk about the Numerati, and Kim Ricketts brought me here, and I was so sorry to see that she had such a nice time. I had such a nice time with her. I was so sorry to see that she had died several weeks ago, and so I just wanted to express my condolences to the Microsoft community and the Seattle community and book lovers in Seattle that she did so much to help and nurture. And I was here for the Numerati, and it was about data and people like you who understand and work with data. And this one is about people like you building a great machine, but it's just people like you who work at IBM. So there's something in common. Now, when I was finishing up at Business Week in 2009, and I was going to leave when Bloomberg took over. I could get a deal with severance when Bloomberg took over at Business Week in December of 2009. So I was heading for the exit and looking for my next project. And I had this idea to do a book about what do you need to know, and the idea being that there's information, machines and networks give us information, so much information that they didn't used to give us, and so what information do we need to keep in our heads? And I did a big proposal for that, and I had high hopes for the book, and my agent my editor at Houghton Mifflin said, no, it's too vague, it's an interesting idea, but you need a story to hang it on. You need a tale. You can't people don't want to read about Steve Baker kind of talking to people, wondering what you need to know. You need a story. And she also said, you also don't have any answers. I said, well, I'd get that in research. But she said, no, you can't sell a book based on research that you haven't done yet and convince us to buy it. So So then I was having lunch with these people at IBM. This is November of 2009, and they told me about this Jeopardy computer, Watson, that they were building that was going to take on humans. And I thought, this is my story, because it has a beginning, it has an end, it ends in a championship match, so it can be almost like a sports story, a narration that tells about this struggle with this idiotic machine in the beginning, and gradually the machine gets smarter and smarter, and in the end, it has this big confrontation, and we don't know how it's going to turn out. So that was the kind of story I wanted to write. I do a proposal, and I tell my editor, Amanda Cook at Houghton Mifflin, we cannot afford to sit on this book the way we sat on the Numerati for a full year between the time I wrote it and the time it was published. This is news. This is happening. This event is going to take place in January. The TV show is going to be in February, and we have to run like hell and get that book in the stores by September 2011. And she said, we're going to have to run a lot faster than that. What I want you to do is do the first 9/10 of the book by November, this last November. We edit that over the Christmas holidays. You go to the match in January. You write the last chapter a couple days after that match in January. And then after the day after the TV show, we start selling the book. And so that was her idea. And then somebody at Houghton Mifflin said, there's so much anticipation to these events, before these events. There's all, like, they're going to be hyping the hell out of this thing, and we want something to sell during that period. So what we're going to do is try to convince Amazon to sell a partial ebook, Amazon and B&N, a partial ebook where they'll sell the first 9 chapters a few weeks before the event, and then ebook readers can get the final chapter sent to them as an update right after the event. So that's what we ended up doing, and I thought it was kind of innovative and fun. And there were some glitches, but that's what it was. So I should mention that if you do read the book, I thought it was important to get Microsoft's voice in this book, and it's not an easy thing for Microsoft to participate in a book that might turn out to be lionizing engineers at IBM. So I didn't get Microsoft, but I did try, and I regret not having Microsoft's voice in there. Now, this story began in 2005. IBM has, as you know, has these grand challenges, and part of the reason they have them is because they don't have anything to sell to consumers. IBM, when I was a kid, was the preeminent tech brand. People wanted IBM typewriters, and later they wanted IBM computers, and now nobody buys anything that is associated with IBM, and so they don't have a brand that people know about as Microsoft does. And so they come up with these things, and these are contrivances, these grand challenges, and they're often criticized for them because it's looking for a lot of PR and it has a lot of hype around it. But they would argue that they serve a purpose, and I happen to agree. And they'd had a chess match in 1997 where Deep Blue beat Garry Kasparov, and then they did a Blue Gene, what was at the time the fastest supercomputer, and that was supposed to be the next grand challenge. It didn't get as much publicity, and they were looking for the next one. And the head of IBM Research, Paul Horn, was walking around research trying to get teams to sign on to a Jeopardy challenge. And he couldn't find anybody that was interested in it. First, Jeopardy seemed to be kind of cheap, kind of crass. It's a quiz show. It doesn't have the elegance and the sort of the eternal value of chess. It's just a quiz show that's run by a company that puts advertising on it. And so I think researchers were a little bit hesitant to sign up to build a machine to play Jeopardy. It seemed a little bit trivial. And they deal with trivia. And secondly, it was hard because IBM had a question answering system called Pequent. And every year it took place in these government-sponsored tests by the NIST competition. And Pequent had all kinds of troubles, and it topped out at about 35%, a 35% range on questions that were much simpler than Jeopardy questions. And plus, it had a lot of time to deal with each question. So I'll give you an example of a Pequent, a problem with a Pequent question. One of the problems is it had trouble figuring out what it was supposed to look for. So in this one question says, what is Francis Scott Key known for? Now that seems like a pretty easy question. But if you ask a computer what something's known for, what does known for tell you? Is it known for doing something? Is it known for being something? Is he known for being the victim of something or the plaything of something? It wasn't clear, and so those sorts of misunderstandings hobbled their computer, and as I say, it got about 1 out of 3 questions right. Now Jeopardy you have to answer a question in 3 seconds. And it's an incredibly wide domain. And sometimes just figuring out what you're looking for is very difficult. I'll give you an example. Here's one Jeopardy clue. I'm paraphrasing it, but his daughter and granddaughter, both Indian premiers, were assassinated. So, what is the computer looking for there? It's not looking for a daughter or a grandson. It has to figure out the relationship and say, if his daughter was killed, then we're looking for a father. And if his grandson was killed, we're looking for a grandfather. So teaching the computer to make that kind of assessment turned out to be really challenging. And another thing that spooked them from the Jeopardy game, in the beginning they thought their computer would have to have voice recognition, and that would just add much more complexity and difficulty to it. So they couldn't get anybody to do it. But Horn tried again because he was getting pressure from above, and they really thought that the future of their consulting business was building technology to grapple with oceans of unstructured data that was flowing across networks. So he finally got David Frucci to sign on, but he only signed on conditionally. Now, Frucci, who you've probably seen on if you've been looking at the website or you see him on the television commercials, he is a highly neurotic New Yorker. And he is extremely loquacious. So he'll talk and talk and talk, and he's very nervous. And so he makes for a great source for a book, because the guy talks about anything at great length, which is great for me. He'd been working in semantic analysis and building a software platform an analytic platform to deal with different streams of unstructured data. It was called UEMA. And that was one of the reasons he turned down Jeopardy the first time, because he was busy with UEMA. But he finally said he'd take it on. This is early in 2007. But he said he needed 6 months for a feasibility study. And he had two big issues. And both of them had to do with working at a big company, a big research outfit. So I thought it might be relevant to you. First, one of his fears was that it would be too hard and the machine would fail and embarrass the company, embarrass him and all his researchers. The second fear, which is sort of the diabolical twin of that fear, was that it would be too easy. And that after IBM pumps all this money into it and all of this, maybe all the hype already starts, and some college kid peeks out from his dorm and says, I think I have this figured out. I kind of did it with a search engine and some open source stuff, and that would be his nightmare. And so he figured he would try to simulate that by getting one of his researchers to pretend that he is what they called a basement hacker. But he had another problem, Frucci did. This Pequent system, this system that got 1 out of 3 right in the question answering, he wanted to kill it. And inside the company, there were people who had supported Pequent, and Pequent had a certain constituency within IBM research, and he had to basically figure out how to kill Pequent. So what he did was he set up his researcher, James Fan. He just come from the University of Texas, and he put him apart from the rest of the team, and he said, I'm going to give you 30 days to come up with a Jeopardy machine. You can use search engines, you can use Wikipedia, you can use the whole internet, you can use any open source software you get, anything that anybody else would get. You can use it. Do the best you can in 30 days. And meanwhile, he told the Pequent team, your machine is going to be facing the basement baseline in 30 days. But don't do anything to it. Like he basically just changed it so that it answers questions in the form of a question the way Jeopardy does. So Fan takes off on his mission here, and he looks for all kinds of simple solutions because he doesn't have much time. I'll give you an idea of one of his solutions. He types the entire convoluted Jeopardy clue into a search engine query. And then he looks at the first page of results. And the first page of results often points to a Wikipedia page, and the title of that Wikipedia page occasionally is the correct answer for the Jeopardy clue. Now that would only work for maybe 5% of Jeopardy clues. You could not build a system, a functional system with that, relying on that type of algorithm. But he thought that if you had maybe 100 other algorithms that were equally clueless in every other area, but in their one area of specialty, maybe together they could provide 60, 70, 80% of the answers. So that was sort of the idea, the fan's idea. And he built his machine, and it had all kinds of weaknesses, but in the bake-off, according to a couple of different metrics, it matched the Piquant. And so Frucci killed Piquant, and he used what the architecture that Fan had designed for the Jeopardy machine. So in mid 2007, he sends a memo that says, we will do this. Within 3 to 4 years, we can build a machine that will be competitive with championship caliber Jeopardy players. And in 5 to 7 years, it'll be invincible. But he said he didn't think it was worth it to spend the money to make that extra 2 years to make it invincible. There was no business case for making an invincible Jeopardy machine. So they built a system that has all these competing algorithms that come back down, each of them bringing its own candidate answers, and then it's up to the analytic engine on his UEMA platform to sift through them and figure out which one it has confidence in and whether it has enough confidence in each answer to bet on it. So I'll give you an example of some of the problems they faced. Chile's, no, I'm sorry. Shoot. Okay. Argentina's longest border is with this country. I already said it. It's Chile. So they give that to the Watson, what was at that point called Blue Jay, and all of its algorithms go off hunting, and some of them are specialists in limericks, and they bring back absolute garbage that has to do with South American limericks, and some of them are specialists in pun detection, and some of them are specialists in things that have to do with numbers and math. And so they're all bringing back garbage, but 2 of them bring back something that's close to the answer. One of them is kind of like a search engine type algorithm that looks for how many times other borders are mentioned with Argentina's border. Or Chile's border. Anyway, Chile's border. And another one is a geography specialist. And so they both come back, and the search engine one says that the answer is Bolivia, and the geography specialist comes back and says the answer is Chile, or Argentina, whichever one it is. Anyway, it picked the wrong one. It paid attention to the popularity instead of the geography. So they have to go and look and see how it came up with that, and what evidence it was looking at, and how it was weighing that evidence. And then they go and they change the weights a little bit so that on that type of question it'll pay more attention to the geography specialist rather than the search engine specialist. And then they have to go through thousands of more questions and see whether that screws up their accuracy in other areas. So that's sort of what they were doing day after day, tweaking all these different algorithms. Another one that they came up with was called nested decomposition. And that is important because there are many Jeopardy questions that require 2 levels of analysis. So this is one of them. Of the 4 countries that do not have diplomatic relations with the United States, this is the farthest north. So again, all the algorithms go out in their hunt and bring back their ridiculous limericks and parables and things like that. But one of them has the sense to break the question into 2 and say, okay, what are the 4 countries with which we don't have diplomatic relations? It's Bhutan, Cuba, Iran, North Korea. And then it hands it over to a geographer, just like a human would. The geography part of it goes and looks and finds out which one's farthest north. So that's the nested decomposition. Then they had another category in Jeopardy called before and after. And before and after is a specific thing to Jeopardy, which is 2 concepts that would have nothing to do with each other except a shared word in the middle. So there's one that says, this candy bar is a Supreme Court justice. So it's Baby Ruth Ginsburg. Baby Ruth is a candy bar. Ruth Ginsburg is the Supreme Court Justice. And so they trained Watson to do that. And Watson could startle people with its ability to do those sorts of ludicrous before and after questions. And this raised a concern among IBM people, and especially Frucci, because it raised the question of whether they were spending a lot of time training a machine to basically win a quiz show. And they were, as researchers, as you can all imagine, they were very, very sensitive to the subject that they were participating in a big PR extravaganza where they're going to spend a lot of time and a lot of PhD hours fine-tuning a machine to win a ridiculous game. And so they would always stress, yeah, we taught it these before and after algorithms, but it only took a tiny bit of our time, and most of our attention is focused on creating advances in English language or natural language systems that can answer questions and dig through data. And so it was always a sensitive subject for them. And that subject came up also in strategy, because strategy was another area where clearly they were training the machine to win the game, and it didn't really have anything to do with what the machine was going to do in its career after the Jeopardy game. And so they always tried to sort of de-emphasize the amount of effort they were putting into the machine's strategy. Now, they had this guy, Jerry Tesoro. I don't know if any of you know him. He is an IBM researcher who specializes in games. And in the 90s, he created a system where basically machine learning system to train a machine to be a champion at backgammon. And it goes through millions and millions of simulated games and learns incrementally and about the calculating each move and the probabilities with each move, and it became a backgammon champion. And so he used the same system for Watson, trying to figure out how much Watson should bet if it lands on a daily double and it's behind by $1,000 with 10 questions to go. And so they figured that out, and Watson, and they came up with a conclusion that humans underbet dramatically. Humans are timid and tend to pay way too much attention to the risks involved and not enough to the rewards of betting heavily. So they went to Frucci and said, we've got to get Watson to bet much more aggressively in these daily doubles in Final Jeopardy. And Frucci blanched at the idea because it was scary to him that in the one game or two games when this machine is on national TV, a game that would have a lot to say about where his career was going and his team, that Watson, even if it made statistical sense to bet a lot, if it lost one of those big bets, what then? If it makes sense in a million games when there's no cost to losing for it to bet aggressively, that's not the same as if you're on national TV and there's a high cost. And he says, you guys didn't represent the cost of what embarrassment means to us and what humiliation on national TV means. And you've got to incorporate that into your analysis. And so what they basically did was turn their back just a little bit on the statistics that ran the whole program and go back to the old ruling by the gut and returning to what humans always do, which is look out for things that might kill you. And so they had to kind of rejigger and make its betting strategy a bit more conservative than the statisticians wanted. When they at about this point, while they did the questions on one server, it took Watson about 2 hours to go through all of its calculations, and they had to get that down to 3 seconds. So they scaled it out to over 2,000 cores, and that was a big effort. And I don't write that much about it in the book because I'm not a hardware guy, but it was a big deal, and they finally got it down to about 2 or 3 seconds, and they also sort of pre-structured a lot of the data so that it was already analyzed for the for easy reading for the computer, that so and so is a noun, and here's a verb, and this is the object of the verb, and this is a name, and this is a county, and so all of that was spelled out so the computer could speed read. And its data cache at this point was about 75. Its data load was 75 gigabytes, and then that structuring took it up to 500. And then they had to run the whole thing on RAM. When they were, as Watson kept improving its performance, they had this chart, and it was called the Jennings Arc, and it was named after Ken Jennings, who was the champion who they were going to face in this match. They didn't know they'd be facing Brad Rutter, but they knew they'd be facing Jennings. And so it was the amount of time they buzz in, and the amount of questions and the percentage of the questions they get right. So in the upper right are the Jeopardy champions, because they buzz in a lot and they get most of them right. And Watson was down here with like third grade level people and was moving up. And they had this big blue cloud of Jeopardy champions. Then you had the red dots, and they were Ken Jennings, and he was sort of like an outlier. He was higher performing than and they had to get there. And they were making good progress. But when I started researching the book in the spring of 2010, they were having their first sparring matches. And Watson was winning about 2 out of 3 against former Jeopardy players. So it was good players. It was winning about 2 out of 3, but it was making some really embarrassing blunders. One time when it was asked about the diet of a butterfly, Watson said that butterflies eat kosher. And one time it was asked about a famous French bacteriologist, and Watson answered, "What is, how tasty was my little Frenchman?" It was the name of a 1971 Brazilian movie that he'd come up with somehow. And so this was a real concern for them, because, again, Watson could get most of the questions right, but when it didn't know something, it was a horrible guesser, because it didn't have any the kind of contextual smarts that humans have. So if it's looking for something, it looked for Oliver Twist, who's a character in a Charles Dickens 19th century novel, and it came up with the Pet Shop Boys, who were a 1990s techno band. And so they had teams that were focused on where can Watson embarrass us, and let's go in and troubleshoot the areas where it's most likely to embarrass us. But the areas where Watson could embarrass them were as broad as the world of knowledge itself. So it was kind of a futile thing. And what's more, if you think that they only had 120 questions in the 2 games that they were going to play, the chances that the embarrassment that you steered clear of is going to be one that comes up in that game is remote. So as I tell you, David Frucci's a very nervous guy, and one day last spring he comes to lunch with me, and he's basically flying off the handle. He's extremely upset. He's just been on a 2-hour conference call with the folks at Jeopardy. And they've told him that the machine, as he has it, and he and his team have it, it's buzzing too fast. And they had the machine basically just buzzing electronically. And they said, it's going to kill the humans. You've got to create a finger for that machine. And so for Frucci, first of all of his data from the sparring sessions was going to be, as he saw it, no good anymore if you change the nature of the machine. Secondly, he said, you are trying to graft human limitations on my machine. We've built a brain, and you're trying to turn it into a robot. And what's more, if we build a finger and the finger is really fast, are you going to come in and say, no, I'm sorry, that finger's a little too fast, and slow it down a little bit? And are you going to do other things to try to balance it? And he said, why don't you, if we're trying to even the playing field, my machine is clueless when it comes to language. Why don't you have the humans deal with ones and zeros a little bit instead of everything being done with language? But he lost that argument. But then he knew he was going to lose it because he knew on TV people were going to say it was unfair if his machine was sending emails. So his bigger question, which really freaked him out, was the potential of bias in the questions. Jeopardy has about 9 people whose full-time job it is to write Jeopardy clues. And these people were going to be writing 15 Tournament of Champion games, and the computer was going to be in 2 of them. And he said it was impossible for them to forget that they were writing potentially for a computer and to write questions for humans, which is what Watson was trained on. He said, this is going to be turned into a Turing test, where you're basically, whether you're doing it consciously or subconsciously, you're going to be slanting the questions against the machine, which he often called my machine. And so he would get on the phone with these Jeopardy people and have big arguments with them. And you have to understand that Jeopardy comes from the world. It was born in the 1960s, right out of the quiz show scandals. And the quiz shows in the 1950s were crooked. They were bought. And Congress went in, President Eisenhower expressed indignation. It was a national scandal, and quiz shows were subjected to scrutiny and to a regime that I would say is much more stringent than anything the SEC has on publicly traded companies. And so they do everything. They have all of their procedures. It's like for the space shuttle or something like that. Every contestant has to have an escort. The contestants can never be in the same room. If the board stops working, they have to turn their back to the machine, and somebody has to be talking to them to distract them so that they're not thinking about the game. They have all of these procedures, and for a researcher in a major project that they're undertaking to bring up the idea that their question writing was biased, was poisonous to them. So I went out and talked to the chief of Jeopardy about 2 weeks later. His name's Harry Friedman. He's the executive producer, and he works on the Sony lot in California, in Culver City, which is part of Los Angeles. And he told me, basically, we're stepping back. We don't know if we're going to do this project. This was in May, and I was supposed to deliver my first chapters in July, and I had this whole thing running, and it was devastating to me that he could step back, but I think he was engaged in a game of chicken with IBM. But anyway, it was a pretty nerve-wracking time. In the end, they found a bunch of Jeopardy clues that had already been written, and they used those for it, and that satisfied Frucci, and they got past that bump. Now, there were a lot of people. Part of my challenge writing this book was to write not only about Watson, but about the broader implications for artificial intelligence and question answering. So I talked to other people in AI, and I've met a lot of skeptics. A lot of people were skeptical about the Watson program, not only because it was full of advertising and promotion, but also the very nature of the computer itself. There are people at Vulcan here in Seattle who sponsor a project called Halo. And the Halo project attempts to actually teach the computer concepts, and so that it comes closer to understanding, so that it can reason based on things that it knows. So you teach it chemistry, and the idea was teach it enough chemistry so that it can pass an advanced placement test in chemistry for high school. Watson could not do this because Watson doesn't know anything, and Watson certainly cannot reason based on the answers it comes up with. Those are just strings of ones and zeros as far as Watson is concerned. And so, but the trouble with Halo is that it costs about $15,000 per page of a textbook to teach this information to the machine. The machine is limited to what you teach it. It can't reason outside of that, and so it can't really get past human intelligence at all. It can do a more efficient job of conveying what humans already know. And if you go outside of what it knows, it's very brittle and can't really deal with it. Then I went to the other extreme. I went to MIT and I talked to this researcher named Joshua Tenenbaum, and he was skeptical about Watson for a different reason. He went over that before and after, the Baby Ruth Ginsburg thing, and he said, okay, I've only seen a before and after one time, but then he made up a before and after. And he said, so I forget what it was, Thomas Jefferson Davis, a founder of the Republic who later led a rebellion against it. And so it was Thomas Jefferson Davis. And he came up with that in a minute. And he said, see, that's what human intelligence can do. Human intelligence not only can understand and answer questions, but it can figure out how to create new ones. And his idea is that we are just at the beginning of a long path towards truly smart machines. And he compared smart machines to the Apollo project. In 1960, Kennedy says we're going to go to the moon, and in 1969, people go to the moon. And he says that project began with Galileo, writing mathematics expressing motion, and then it goes through the whole scientific revolution, and the science was carried out from the 1500s till 1960, and then the science was mostly settled, and then it was the engineers that take science and send the man to the moon. And he says, in terms of understanding the brain, which is where we're really going to get intelligent machines, we're only at Galileo now. So he went to the other extreme. And Frucci would agree with him, but he said Frucci has to build a machine in 3 years that can play Jeopardy, and he doesn't really care if you call it smart or not. And it isn't. I mean, it's not smart. So, anyway, the match is getting close. They have a team that's called the Stupid Team that is focused on how Watson can embarrass itself, especially in Final Jeopardy, because it's a bad guesser. In Final Jeopardy, it has to answer, even if it has low confidence. In many other questions, it doesn't understand them, it doesn't have confidence, it doesn't bet, it doesn't make a fool of itself. In Final Jeopardy, they worried that it might make a fool of itself. And so they actually considered the idea of having Watson shrug its digital shoulders and say, I don't know, because that would be a much smaller embarrassment than what eventually happened. Watson wins the game. I went on that January afternoon, and those poor humans, the set kept breaking down, and you see it on TV as 3.5 hours, but it went on for hours and hours. And well, the machine didn't suffer at all, but those humans were going through hell. And plus, it was like they were on a visiting team because the whole crowd was cheering for the machine. And so they had a really, it was tough for them. And Watson embarrassed itself, as I'm sure many of you know, with a category. It was U.S. cities, and it guessed that Toronto was a U.S. city. I'll be happy, if we get the questions and answers, I'll be happy to walk you through why it made that mistake or how it made that mistake, but I don't want to deal with it now. After the show, I'm writing my last chapter, and the Sony people call me and say, Alex Trebek wants to talk to you. Now, Alex Trebek is the host of Jeopardy, and he was a good sport during this because he had to entertain the crowd while people fixed the machines behind him for hours. And he was very upset, because he said that the IBM people had not played straight and that they had sandbagged. And sandbagging is a term you use when you pretend you're weaker than you are. If you're at Las Vegas, like you don't have a good hand or something like that, and then you put down your winning cards. And in the test matches where Watson played Ken Jennings and Brad Rutter the 2 days before this competition, Watson pursued a very dumb and elementary betting it just went straight down the board from the easiest to the hardest questions. And once the game started, Watson began hunting the high-value questions, looking for daily doubles. And so Alex Trebek said that they flipped a switch and made it a smarter machine, and that was not fair. And the IBM team said, well, we were just testing out the electronics in the test matches, and then we turn it to match play. And anyway, we'd send a DVD to Ken and Brad, and they'd seen that Watson shops for daily doubles. And Ken and Brad said that they sandbag regularly in test matches, and so why shouldn't a machine? So it wasn't as big a deal for them as it was for Alex Trebek. Now, after the show, there was all kinds of criticism about Watson. And it was as if humanity was offended that this machine had beaten humans in Jeopardy. And for the good of humans, they were arguing back and saying, Watson doesn't know what it is. True. Watson doesn't know anything. True. Watson won because it was really fast on the buzzer. Well, that's true, but you have to take into account that they had to have it get the right answers a whole lot of time for the buzzer to make any difference at all. Because if it's fast on the buzzer and gets the answers wrong, it gets killed. So I give them partial on that. But the long story is that people wanted to denigrate Watson and show that human beings have superior intelligence. And this is true. But I think they're missing the point. And the point is that this type of technology is coming, and I'm sure some of you are working on technology like this that might be competing against what IBM's doing, and it's not going to be too long when Watson is going to seem like an extremely primitive, highly wasteful machine that answers questions, because we're going to have much more intelligent, much more efficient ones in every area of our lives providing answers for us in all kinds of industries. And so I wrote a fable for the Wall Street Journal about this. And it goes like this. Imagine you're in 1550 in Italy, in a little town, and there's this one man in this town who's brilliant. He can sense by the pattern of birds and the feel in the air and the noises coming from the barn, and many other data that's coming in. He uses these immense powers of pattern recognition and intelligence that he has to know that tomorrow it's going to freeze or tomorrow it's going to snow. And this guy is the weatherman in this town, and he uses his human genius to come up with this analysis, and it's very valuable. And then a wagon comes into town with a big new instrument in it, and it's a barometer made in Florence in the 1550s. And the barometer doesn't know who it is, isn't intelligent, doesn't know what it's doing. It's just an idiotic machine, but it produces the same answers that this guy did with his magnificent brain. And so forget about what's so special about the human brain and just say, we're going to have machines, and many of you are going to build them, that answer our questions. And so what are we as a society going to need to know to basically make a living and advance beyond the machines and use our intelligence to use the machines to keep our jobs and make the world a better place? And so I think that's the challenge that we face as a society as these machines march forward, as I'm sure they will do. So that's my talk, and I would be very happy to answer any questions that you have about IBM, Watson, anything else. Yes?
Excuse me for coming in late, so you may have mentioned this. You at one point in your talk said that they decided to use questions from previous Jeopardy games. And my fear is that the IBM team had run 20,000 or more questions through Watson to see how it did. What if too many of the questions they ended up using in the game were actually part of the ones?
Okay, I'll go there. They had a training set of 180,000 previous Jeopardy questions, and they hadn't gone through all of them, but they'd gone through many. They'd gone through more than 100,000 of them. I misspoke when I said previously written Jeopardy games. They had not been used yet. They were written for the season that was coming up, that was going to start in June. They wrote 100 games for the season that was going to start in June 2010 and go through November. And they could take 30 of those and use them for this. Then they hire a company that specializes in making sure that they do everything by the books, and they choose them and do all that. So it was ones that had not been used before. Yes?
A technical question about the buzzing.
Uh-oh. Yeah?
So how is Watson given the clue? Because a human still needs some fractional time to read the clue.
Okay, Watson.
So is there still an advantage there?
Watson gets it as basically an email, right? It just gets text.
Right.
And then it has to parse the sentence and figure out what's the subject, who's the direct object, and all of those types of things. So I would argue that humans have the advantage when it comes to reading a sentence quickly. I would argue that that's one of the areas it doesn't have an advantage, because it can misunderstand a lot of these questions.
We've worked on a parser ourselves, so we know.
Oh yeah. Well, I mean, that was and so it took, I think, it took about a half a second of those 3 seconds. A half a second was usually needed for parsing. Yes.
You mentioned in the book that there was some sort of a blocking that they use in the games when humans play, that you cannot buzz too early. So they do have there's a fair playground, because you can't buzz too soon. But they have a mechanical or electronic way of ensuring that it doesn't buzz too soon. So I think that's what you were asking.
Well, the other thing is, see, the way it works is there's a human who's sitting at the judges' table who listens to Alex Trebek's voice, and when he judges that Alex Trebek has finished reading the clue, he hits a button that turns on a light and opens up the bidding. And so the way humans, like Ken Jennings and Brad Rutter, the way that they turn out to be phenomenally fast buzzers is they anticipate the end of his sentence, and they get a feeling for the rhythms of the voice. And so it's humans understanding humans, and in that way it's kind of like jazz, because you're waiting for that downbeat. And Watson has no anticipation but lightning reflexes. It's about 10 milliseconds once the light goes on. And so the humans are like jazz, and Watson is more like techno. Yes?
So you kind of described the way it was as like they have hundreds, maybe up to 200 of these single category expert systems.
Right.
And then there'd be some layer on top that would say select from those hundreds. Now, how does that work when you also said there was this other problem where these two-level things? It seems like those would be ideal questions to ask, because you can't, each of the ideal things would have an ideal answer, but how do you combine them? You have to do, the second level has to analyze the data from the lower level one.
You mean the North Korea question?
If the question was, this is alphabetically first of the noble gases. Well, he could produce the noble gases, but now he has to sort them alphabetically.
Right.
And so that would be a second level process.
That's right.
And how does that fit into this scheme?
Well, it does the same thing. It calculates just the way a human would. If it works, it doesn't always work, but if it works, it says, okay, what are the noble gases? And then it lists them, and then the second part is list them alphabetically and pick out the first one.
Okay, but you could imagine that the alphabetized guy has to wait for the other guys.
It does. It does.
So they can wire it that way.
Yes. Now you could, with North Korea, you could look at a list of the northernmost countries. It doesn't have to be one before the other. It could look at 100, 200 countries, which one's farthest north, and then look among them which ones the United States doesn't have diplomatic relations with. Maybe it does it that way, but I kind of think about it the human way, which is to think of the four.
Yeah, what if the answer, like, one guy would say Finland or something like that was the answer to that question, because it was more than one. If the order, if it ran it in the wrong order, like...
Right.
I think the point of the final discrimination was on the final answer from each day. It wasn't looking at the separate sub-answers.
Yeah, but the general way of doing it is they have 200 expert systems, each producing a separate set of answers, and then some guy on top choosing between those 200. there's no way to combine the data in the general census that you gave me.
Right. Well, no, each one comes back with its own candidate answers, and then each one develops its own record in each type of question, and so the computer develops more confidence in certain types of questions for each category. So it basically discounts I just get, yeah.
Yeah, so I have two quick questions. So the first is, how did IBM and Jeopardy try to frame this? Because my question is basically, Watson didn't really have many environmental factors taking into a system, so he didn't know how well the other players were doing, I presume. Like, he didn't get that sense of emotion, he didn't get the lights and the awe of being on the set of a TV show,
No.
or he didn't get the intonation of Alex Trebek's voice, all those different environmental factors that humans hear and sense and stuff. So how did IBM try to take that into account? Did they try to make claims that this was a fair match based on the fact that Watson wasn't getting all this types of information, even though it didn't?
Well, they didn't
that
get.
all impacts a human.
They didn't get too hung up on fairness, quite frankly, because they thought that the Jeopardy people were hung up on fairness, and that in a man-machine match, it's never going to be fair because they're totally different things. The machine had no memories of human life and no experiential memories, and like, here's one of the questions that would confuse a machine. When entering, oh shoot, I forget what the word is. Well, anyway, when entering a room, there's this little piece of wood. What's this thing called? Baseboard. Okay. When entering a room, which way do you look to see the baseboard? So humans know, but the machine has never. The machine will have to look for statistical evidence that I look down to see the baseboard in fiction, in literature, or whatever. It would be a very difficult thing for the machine to figure out. So they're basically. What Frucci's point was, it'll never be a fair match. It can only be a fun match, and it can tell us things, but it's not going to be fair.
Rather, just half of that.
Yeah.
Just what was the most surprising thing, not about Watson specifically, but just your whole experience writing the book? Like, what surprised you the most? Was it, it could be the types of people you interacted with, or something technically about Watson, just in general?
What surprised me the most? Well, one thing that surprised, I learned a lot in this book, because I went in, as I do in many projects, pretty ignorant about this stuff. Like, they had to build two Watsons. They had to build a development Watson and a game Watson. So so the development Watson was slower, but would detail absolutely everything that it went, every decision it made. But and so that was that type of thing surprised me. But really, what surprised me was that that a machine could do this. It kind of knocked my socks off, frankly. Yes.
How big was the team in terms of man years?
Well, I'd say between 20 and 25 times 4. So what's that, about almost 100 man years?
And is this the same as the Deep QA project, or are they?
Yeah. It's the branded, fancy promotional name for it. They call it Watson when they want to get on TV, and they call it Deep QA when they want to sell it to American Express. Yeah.
Could you please tell us why Watson made the answer Toronto?
Okay. Watson, through statistical analysis of the Jeopardy categories, Watson learned to distrust them. Because the categories often, the questions weren't directly associated with the categories. For example, you might have American authors, and then the question is about, and then the question would say something about J.D. Salinger's protagonist in Catcher in the Rye, and so it's Holden Caulfield, who's not an American author, he's a protagonist. And then you have others that are just bizarre, like they had one that's called Country Clubs, and it had to do with different sticks that are used in different countries to beat people with. So, in France, it's a bâton. A bâton is a country club. Came up in the country clubs. And so Watson learns to discount, not pay a whole lot of attention to category names. Now, if the answer is Toronto, if the answer it comes up with is Toronto, and it's U.S. cities, that drives its confidence down a lot, but it doesn't kill it as a potential answer. And so Watson basically didn't know the answer. But it came up with Toronto and gave it 15% confidence, which is just minimal. Frucci says anything under 20 is basically garbage. And 12% was Chicago. It should have shrugged its shoulders. It put about 6 question marks after Toronto to show people that it really didn't know. It would have been much better just to put the question marks with nothing. But and the other thing is, because it doesn't understand a lot of questions and it doesn't understand a lot of data, it has to entertain the possibility that it may have misunderstood something or that something unlikely can turn out to be true. So if you look at if you develop a system that is going to talk about male rock stars in American music history, and you have a list of names, and Bob and Richard and what's not, and then you have female names, and Alice is one of them. If the computer is looking and says Alice Cooper, it would say it is impossible that Alice Cooper could be a man. But it has to have its mind open to that possibility that Alice Cooper can be a man. And so it has to have its mind open that Toronto can be a U.S. city, but here it came back and bit them. Yeah?
What was the reaction from the development team about that response?
Enormous embarrassment. I mean, and the funny thing was, it came after a session in which Watson had been utterly dominant, and they had every reason to feel proud of what they'd accomplished because it had just mowed down the humans, and then it embarrassed itself right there. Incidentally, after that second round, even though it screwed up on that question, Sam Palmisano, the CEO of IBM, he was sitting with the Jeopardy people, and they were worried about a good show. And Watson was making a mess of the good show. And the ratings did go down for the third day because of that. And Palmisano comes up to Frucci and says, maybe we should have toned this thing down a bit, dialed this thing down a bit. So, any others? Yeah.
I think it was in the article that Ken Jennings wrote after the game that he said that Watson was having trouble on short questions, and those were the ones that the two of them could do because they were taking less than 3 seconds for Alex to say. And I just want to hear what you heard about that.
Watson needs at least 3 seconds to go through with all of its processes. And so if you have a category in which it just is 2 words, it says, I think it's like, wives of movie stars, and then the only clue is Demi Moore or whatever, Ashton Kutcher or whatever it is, then that doesn't give Watson enough time. And in that category where they were racing, the humans were beating it, Watson was getting them all right but coming in late. So.
Let's do one more.
One more?
So do you have any, after talking with all the IBM guys over the years, do you have any hunch as to what kind of next challenge they might have?
I don't have, I know what Frucci wants to do. He wants to basically build a crowdsourced system where Watson learns to ask questions and can use the world to educate it. And build up a big data, build up a sort of a knowledge base that way. But I don't know about what their next ones would be. But I'd like to know if this is something that you folks would like to work. This idea of the 25 people working for 4 years on something, is that something that Microsoft should be doing? There are only a handful of companies, like 3 in the whole world, that could do a project like this, and you guys are one of them. I think it'd be fun. And I'd like to write about it, incidentally. If you guys pick something really fun to do, I would love to come out here and do another book like this one.
Thank you, Steve.
Sure. And